station today from Energy Expected.
Okay, so welcome back to our channel for more tutorials. If our tutorials are helping in any way, please subscribe to our channel. It gives us energy to keep producing and to keep researching for these tutorials, for this information. So today we are going to be talking about solar systems in relation to lightning. From experience, one of us and a few moments in a lifetime we witness lightning strikes, and certainly maybe one of us as technical people have installed a system that was struck by lightning, and as clients we have experienced possibly a loss due to lightning strikes. So today I want to cover a short brief of what we can do to make sure that at least we give not 100% but at least 90% protection against lightning to our solar systems. So what does lightning do? Lightning induces a voltage surge, and a voltage surge, I can define it as a transient in nature voltage rise that is above the threshold of what our electronic equipment in terms of the solar systems can withstand. Therefore, the result would be current flowing from all directions to the ground, thereby damaging everything. Lightning damages almost like the boards of the inverters, controllers, and all. So we want to try and minimize the risk of losing our solar systems, especially controllers and inverters, to lightning. So there are two entry points that can lead the surge to access the inverter or controller. One, it could be through solar panels to the controller or to the inverter. If it is a hybrid inverter with everything, then it's straight to the inverter. If it is through the controller, then the first port of call is the controller. The controller will be hit first, right? And then the second entry to the or access to our inverter is through the electricity mains line. So that is another route to which lightning can come through, and this lightning can come through in two ways. It can strike directly onto the panel frame or directly onto the conductors that are coming through the house, the electricity mains lines, or it can be through induction. By that I mean we can have a very stormy weather where there are a lot of clouds, and so it could be from cloud to cloud. The lightning could strike from cloud to cloud. That is when there's a voltage difference or a potential difference which is significant enough to cause ionization of the air between them such that current flows. That is one way in which we can have induction onto the panels and onto the cables. So, but the same effect is that we have a voltage surge, or we have a potential rise against the ground. The ground will be zero, and then we have got this point rising up to more than what is supposed to be. For example, we are in Zimbabwe. The voltage magnitudes is a nominal voltage of 230 volts for domestic use. So that is the nominal. That gives an RMS value of we are having 230 volts. That gives the maximum instantaneous voltage of around 350 volts thereabout, Right. So above that would be a record of a sage. That's where it starts. So, and take note that there's a difference between a voltage surge and an over voltage. Here I'm talking about a voltage surge. That spike in voltage that happens in microseconds. An over voltage is a different characteristic and is taken care by different mechanisms. This one is taken care by protection in the main network, distribution network or transmission network. That is what caters, that is what provides protection for over voltages, because these are for long periods and they are different from the surges that we are addressing here. So the other source of surges is coming from activities in the grid, such as switching. So if such as switching. So if we have got some switching happening in the grid, like putting in capacitors or putting in reactors for voltage control, that can arise into a surge that can then be transmitted to house owners and so forth. Or if there is an industry which is starting a big motor, that can also result in voltage surges and voltage instability of some sort, right? So we've got methods that we can use to protect our systems, and these are the ones that I am now getting into. So one, we can get our house to be covered by a lightning spike, right? Putting spikes overall is like you've protected the entire place, because the part that is going to be hit first is the tallest. So a lightning spike is made such that that is the part that will be the first culprit. But however, that's its job, to direct the surge current to ground. Right? Take note that I am now saying the surge current, because once we've got a surge voltage and then the air around is ionized, it conducts. So what will flow now is the current. So the current is the one that will now flow everywhere in the electronic gadgets. In other words, the dielectric strength that is in between, if you were to imagine if these are cables, there is a dielectric strength between this cable and this cable. So with a surge voltage, this dielectric strength can become so low such that it will conduct. So in other words, it will like it have provided a short between these two conductors. So you can just imagine the printed circuit boards. The conductors are very close to each other. You can imagine the solar panels, the conductors are close to each other. So that is what we want to protect against, the flow of current through parts that are not designed for such current flow. Right, so the lightning spike. So the next method is by earthing the solar panel frames, right? A solar panel has got a frame. So by providing a solid earth to the solar panel frames, what we are saying is, whatever strike that we get, whatever voltage rise that we get, we should instantly ground that to earth. In other words, whatever is going to flow for that moment in microseconds should be conducted to earth instantly. Still along that path from the solar panels to the inverter or charge controller, we can put what is called a surge protective device. So a surge protective device is a device which is so intelligent enough to know that this voltage is now a surge voltage, and as such I should ground it, or I should make contact such that the excess current flows to earth. There is a way in which it is connected. All technical people are aware of how it is connected. So for clients, it's just a matter of providing that gadget or buying that gadget, and then the technical people will install that gadget. Right, from the mains now, from the electricity main line, we can still have these surges. We say this Spd device, special protective device, surge protective device, that can be used for AC side this time. to ground that excess voltage, that excess current. So the moment voltage is above a threshold, then the surge protective device will ground that. How does it do so? It's about its design. It's a device that there's so much resistance when the voltage is at some level, say 350 volts. But when the voltage is now 500, that resistance reduces to almost zero, such that it's like a solid connection to earth. So it connects directly to earth. So I thought that we should get to know about lightning and its effect. We've lost so many systems to lightning strikes, but we can surely do something to try and minimize the effects of lightning, especially in the rain season. So many systems have been struck, we've lost so many systems, but sometimes we put these things, the system is safe for years. Yeah. So from experience, these protection systems works, of course not 100%, because it also can fail to react in the time that lightning would have struck, because it's microseconds. We're talking about microseconds precision here, so it's not that easy. But at least let's have those systems installed. Let's have those protection devices invested onto. Let's not just put a blank system with no protection, hoping that it will be spared. Blind faith, you know, that kind of blind faith that no, this system will be spared by lightning. Let's not do that. Let's put all necessary protection mechanisms. So for today, we are not going to be talking much. I'm sure let's just concentrate on this important subject of trying to protect our systems from lightning strikes. Thank you very much. If this information was helpful, please subscribe to our channel for more videos, and please give feedback, ask questions. We are here to answer you as Maxutra Reliable Energy Solutions. Thank you very much.
Book a free consultation today from Energy Expert.